exponential function. There's our basic exponential curve there, a to the power of x. That is, of course, when the base is bigger than 1. We get that shape. When the base is in between 0 and 1, then it flips. It goes the other way. The domain, or real x, there is no break in it. The range, though, is y is greater than 0. Now, remembering that when we have y equals function negative x, the effect of that is also to reflect it in the y-axis. So these curves could also be written as the first one could be y equals a to the minus x, where the base is in between a and 1, so the blue one has flipped. And then this one could be written as y equals a to the minus x, where the base is bigger than 1. So the red one has flipped. They're all the same curve. Okay, what about our log function? Now, they're inverses of each other, and we saw with inverse functions, they're just reflections in the line y equals x. But therefore, the domain and range swap around, so we know the domain of our log, therefore, must be x is greater than 0, and the range must be all real y. And there's the one when the base is greater than 1, so the reflection of that curve. And there's the one where the base is in between 0 and 1. So let's manipulate these a bit. If I wanted to draw y equals the log of 3x, what effect would that have? Well, I could break it up with my log laws and say, well, that's the same as log 3 plus log x. The basic curve we know is log x. There it is. But what have we done? Well, we've shifted it up. Log 3. And so there's our curve. I suppose the other way I could have thought of that one is because I've multiplied the x by 3, I could think of, I've dilated the original curve by a factor of a third, so that x-intercept of 1 gets pushed into 1/3. Our exponential, 2 to the power of x plus 3. We've got y equals 2 to the power of x is the basic curve, and in this case we've shifted it left 3 units, and there it is. It would now have a y-intercept of 8. The log of the absolute value of x. Right? Basic curve y equals log x. There it is. Absolute value of x. So what did function absolute value x do? It reflects it in the y-axis. The other part still stays there because now we're saying it could be plus or minus. That would be y equals log of the absolute value of x. So all those sorts of ideas we saw earlier in the year about transforming graphs and what have you, we can just as easily apply them to these functions as well, the log functions and the exponential functions.